Satyabama Institute of Science and Technology.
I am Dr. K. Sundara Velrani, Associate Professor, Department of IT, Satyabama School of Computing, Satyabama Institute of Science and Technology. Today, I am going to discuss about the topic supervised learning. Before going to this topic, we must know what's meant by supervised learning. It's nothing but we have to give the training to the input data by which how you are getting the resultant data, that we are calling as supervised learning. By giving the training to the raw data, we will get some targeted value. So, by which how you are getting your resultant value. See here in this diagram, this is my raw input data. So, from this data, the data will be given to the supervisor first. So, he will be giving training to the raw data. So, the desired output what we want to get, that you have to split. So, both will be given to the input raw data. So, you can use any algorithm, machine learning algorithm using supervised learning. This supervised learning will be having many algorithm. Using that algorithm, we will be training the data that will be given to the processing, by which you are getting the desired output result. So, this diagram will give me the overall view of how the supervised learning algorithm will work. What's meant by regression? First step, here we are having different types of regressions. So, regression is nothing but statistical method to relationship between the target value and the predictor value. Target value is nothing but dependent variable. Predictor variable is nothing but independent variables. So, the independent variable, how you are relating with your dependent variable, that we are calling as regression. So, here we are having different types of regression. First one is a linear regression, polynomial regression, so support vector regression, decision tree, random forest, ridge regression, lasso and logistic regression. So, these are the different type of regression algorithm. So, first one is a linear regressions. So, linear regression is nothing but statistical regression method which is used for predictive analysis in the database, right. So, here we will be using the two types, simple linear regression, multiple linear regressions. So, in this simple linear regressions, we will be using only one input variable, but in multiple linear regression, we will be using more than one input variables. So, by which we can find out the resultant value from their trained data, right. So, here see for example, if you want to find out the salary of an employee, depends upon their experience or talent or what they are working background, like that we will be find out the salary of particular employee. So, these are the we can predict the value from using the linear regression method. So, this is the diagrammatic representation. So, here linear regression is so y, this is for mathematical equation we will use in the linear regression. First one, y equal to ax plus b. Here y is the dependent variable, x is the independent variable. So, a and b are my linear coefficient, that is my input data, right. So, here see for this example, they are having experience by which they are finding out the salary. So, this comes under the linear regression. So, here some popular applications where we are using the linear regression. So, for analyzing the salary, then salary forecasting, real estate is prediction, and then estimate the traffic analysis. So, in this applications we can use the linear regression. So, this is my logistic regression. So, in this logistic regression is nothing but this is also main supervised learning algorithm is used for classification problem. It is mainly used for classification problem. This is depends upon the dependent variables, whether it is 0 or 1 or yes or no, whether it is true or false. In that condition, we will be using the logistic regression. So, here we will be using functions like sigmoid function or logistic function. In this logistic regression, we will be using the sigmoid function. This is the mathematical equations for regression. Sigmoid function f of x equal to 1 by 1 plus e power minus x, right. So, here this f of x is my output between 0 and 1. So, whether I need output will be get 0 or 1, like that. So, x is my input function, e is my base of the natural logarithm. The same thing here, this is my sigmoid function, the curve will be like S curve. So, this is my function sigma of x equal to 1 by 1 plus e power minus x, right. So, here we will be checking the threshold value. So, each value we will be checking, we will be fixing the threshold value. For each applications, we can check the, we can fix the threshold value. So, the threshold value is above, if I am getting the resultant value, we have to round it the resultant value into 1. So, if we get the resultant value below my threshold value, we have to round it up to 0. So, this is my resultant value, I will get 0 or 1 in this sigmoid function, right. So, this is my next method is classification method. This is another type of logarithmic classification model we are using in the machine learning, right. So, it is mainly used in the data science applications. So, mainly used for healthcare applications as well as the mail filtering applications, right? So this is for classification model, whether it will comes under the each class, for A class or B class, we can divide the class wise. According to the class, we can divide the data and we can store it in the separate class. Types of classification. First one is a binary or multi-class. In this binary classification model, it will predict a prediction between two classes, whether it is valid email, or in this example like this, spam or not spam. So we can split the mail like this, right? So multi-class, it will be comes under like more than two classes. So more than two classes if you want to classify, not only or not two. So two classes, it will comes under the binary classification. More than two classes, it will be comes under the multiple class classification model. So next one is here KNN. This is another one important supervised learning algorithm we are using in machine learning. K nearest neighbors is nothing but we will be forming the class. So in this, which is the target value we will be forming, which one is my nearest value, that we have to find out. We can round off the resultant value by which the nearest value, that comes under the KNN, nearest neighbor classification algorithm. So here we will find out the distance between the new data point and all the existing data point. That is, we are calling as distance between my trained data as well as the targeted data. So what's the values we are getting, that is we are calling as Euclidean distance. So by calculating this distance value, we can round off to the nearest values. So by which we can predict the resultant value. So here we can select k nearest points from which we can closest to new point we can find out, right? So we can assign the new data point to the class table that is most frequent occurring in the k nearest neighbor. So which one is a most frequently occurrent value, that value we can take it out to the resultant value. So this comes under the k nearest classification algorithm by which I can find out my classification value. So see this diagram, it will be clear more. So we are forming the closest value. So class A, class B, class C. So I am forming the classes like which one, what are the values nearest to the particular range of value. So class A will be having some closest value, class B will be having some closest value, class C will be having some closest value. That neighbor value I am forming the classes. So by which, so if I am trying to find out the PT is my target value, that value belongs to which closest value, class A or class B, class C, that I can find out by training the data, right? So I can, from that I can find out the resultant target value. So this is the overall diagrammatic representation of k nearest algorithm. So this advantages is like it's most understand and very easy to learn, and we can implement in many machine learning algorithm. So it's non-parametric, meaning it does not make any assumptions about the data. So it won't assign pre-assumption. What are the classification, it will form the class. That is, what are the nearest values, it will form the class. So that is the main advantage of this. So it can be effective with high dimensional data. So if you want more big data, we can big data analysis, we can go for this k nearest neighbor. So disadvantage is like it can be more computationally expensive and for large data sets during the prediction phases, right? So here this is more sensitive, it may not be performed in imbalanced data set. So if a data set is, if it is balanced, the resultant value you can get as a very good result. The data set is not balanced, maybe you will not get the accurate resultant value. There is some disadvantages in this algorithm, right? So where we are using this KNN classification, so mainly is for image recognition, text classification, then where you want to recommend the systems, like user based on preferences, similar users. Who are all the similar users, if you want to find out, that you can use. Then medical, mainly medical diagnosis. So medical diagnosis, we need text classification also, we need image classification also need, right? So many cancer identifications like this, we need the brain image or heart image like that, or organs image if we want. From that, if you want to find out the any diagnosis diseases, we can use this algorithm. So because it will be supporting all the image recognition as well as the text classification method. So another important is Naïve Bayes classification. Here this is for linear classifier. So it trends for faster when applied to the big data. It's very fast for classifying the data. So this is for highly accurate. So here we will be using the hyperparameters. So it will be offering the hyperparameter for smoothing the data classifications, right? It's mainly used for large data set. So here this algorithm is mainly for probabilities, depends upon the probability I can find out. So if this particular probability is when it occur, this condition will be belongs to this class. So this probability is higher, this data will be belongs to the particular class. Like this we can classify, depends upon the probability of particular data occurrence. That comes under the Naïve Bayes classification. So this is the theorem we are using in the Bayes theorem, right? So that is what I told you now, that is like a probability of A tends to B. So probability of P tends to A, probability of A divided by probability of B. So this is for posterior probability. Then next P of A is a likelihood probability, P of A is a prior probability. What is the priorly we can assign the probability of the particular data occurrence. Then is the marginal probability. This is my last marginal value. What are the probability may occur. So like this you can assume the values of probability of data occurrence. So by which I can find out the resultant value by using the Bayes theorem. So how this example, how it will be work? See, for example, if I am having the data set like weather conditions, so particular data probability will be there, whether it is rain or drizzling or it's more heavy rain or wind. So like this we have to decide. So according to the probability, I want to whether I can go for the target variable. It's like play. If I want to play or we cannot go out or only for walk, like that I can predict my target value. So this is nothing but how you are it will support for probability of the data set, right. So this is mainly used in the first it will convert your data set into frequency of tables, then it will generate the likelihood tables by finding out the probability of the given features. So whether it is rain will come or not. So it will find out the overall probability of each conditions, right. Then you can use this algorithm to calculate the posterior probability, whether I can go for the play or I can go for the walk or I have to be inside the home. So this type of probability of applications we can go for this classifiers. So here, so these are the each classification algorithm having some advantages and disadvantages, depends our applications we can use, right. So it's for mainly for text classification we can use, for multi-class classification we can use, so mainly easy and fast and machine learning algorithm, right, that we can use for this Bayes classifier. This is it won't many assumption is there, right. So independent or unrelated, so it cannot be learned for relationship between the features. These are the main disadvantages in this classifiers. So where we are using this Naïve Bayes classifier, so it's used for credit scoring, medical data classification, same like then real time predictions. That's a real example I said. So weather forecasting, so real time predictions we can go for this classifier. Then it's a text classifier, so mail it's whether it is spam or filtering or sentimental analysis. So text classification or real time classifications are the main application we can use this Naïve Bayes classifier. Why? Because it's mainly for probability of classifications. So that kind of application we can go for the Naïve Bayes classifier. So not but that's the least, this is a support vector machine. Many researchers now they are using this machine learning algorithm support vector machine. So I can say this is a most accurate resultant value you can get by using this SVM, right. So this is we are calling as one of the most popular supervised learning algorithm, is used for regression problem, right. So this will create the machine learning for SVM algorithm to create best line or decision boundary that you can segregate n dimensional database into the classes. So by which you can get the resultant and accurate classified targeted values. So here we will the best decision boundary we are calling as a hyperplane. So whether it is linear or unlinear, like that you can find out. So this chooses the extreme points or vectors to help the creating the hyperplane. These extreme cases are called as in support vectors. Hence this algorithm is called as support vector machine. So hyperplane it will divide the values positive or negative, like that it will be divide. See these two different this is a hyperplane. So see this diagram, it will be clear more. So we are checking with the maximum origin hyperplane. This side positive hyperplane, negative hyperplane. This is my solid line is my maximum origin. This is my maximum origin linear classifier. So here I am saying it's a linear SVM and non-linear SVM, right. So linear SVM nothing but is used as separable line is linear, which means data set can be classified into two classes by using a single straight line. Then such data is linearly separable, positive or negative. So this is we are calling as linear classifier, right. So this is my maximum origin is a solid line. So above this line it will be the positive hyperplane, whether if a predicting value is below this straight line it comes under the negative hyperplane, right. So by which we can classify the data by using the support vector machine. So this is very accurate result mostly we can get. So the most research is going in the by using this SVM classification. So non-linear is nothing but this algorithm is used for non-linearly separated data, which means it cannot be classified by using a straight line. So exact data value is there, now we can use the straight classification value above or below we can classify. So but in non-linear that won't be like this. It's like a non-linear data won't be the straight classified. So that kind will go for the non-linear SVM classification. But overall SVM classification will give me the compared to other good result for classifying and targeted value by draining the data. Thank you. So all the classification model basic we can go through it now. remaining problem we'll see in the next lecture. Each example, each classification algorithm, we'll see the example problem. Thank you.